Hi everyone, in this video we cover question 1 in paper 1 of the 2009 grade 12 NSC exams. By the end of this video you will have gained insight into what each question means, what is being tested, and how to go about answering these questions. I wrote this exam back in grade 12. Give this video a thumbs up if it helped you, comment if you have any questions, and subscribe to my channel if you want to get 100% for maths. Getting 99% for maths means you still need to learn 1%, and we aim high on this channel. The link for this exam is in the description below.
Now look, we're going to be dealing with some real serious stuff today. You might have heard of it. It's called math.
Question 1.1 asks us to solve x. But what does that mean? Let's look at question 1.1.1. Here we have a left side and a right side. We can plot these two sides as functions on a Cartesian plane. Note that these two graphs cross each other at points minus 530 and 630. The question solve x can thus be interpreted as find the x values where the formula on the left is equal to the formula on the right, or what are the x values of the points at which these two functions cross. We are going to solve this by doing some algebra. First, we rewrite the equation. To find x, we want either the left or right hand side to equal 0. Multiplying the bracket is easy, and now we need to deal with the 30. So let's pause right here. This is the first and arguably the biggest mistake I see my students make. They like to use words like, we take the 30 over, right? No, not right. This is an equation. If we want to get rid of the 30 on the right hand side, we need to subtract 30 from the right hand side. And what we do on the one side of the equation, we need to do on the other side of the equation. The equation must balance. Getting this right will step up your math to a whole new level real quickly. Watch how I do it. By subtracting 30 on the right hand side, we can get one side of the equation to 0. This is what we need if we want to factorize going forward. Note that we now have a parabolic function which we can factorize into two brackets. I'm going to do this by shorthand, but if you want, you can also do this using the formula on the formula sheet. With the shorthand method, we need to find the factors of 30 that will give us a difference of 1. The largest factor goes into the negative bracket. If any of you would like an explanation of what just happened here or parabolic factorization, please ask for it in the comment section below. If I get enough requests, I'll make a separate video on it. We can write each bracket separately because if either of these brackets equals 0, the whole left hand side will equal 0. Again, we balance each equation and find the values of x that will satisfy the question. Full marks. In question 1.1.2, we are asked to report the answer to one decimal place. This is a dead giveaway that we will be using our calculators. The cool thing is that the equation has already been simplified, so all we need to do is punch in the numbers correctly, right? If we plot this equation, we can see it crosses the x-axis at 1.434 and 0.232. Thus, the question can be interpreted as find the x values where y equals 0, or find the x values where this function intercepts the x-axis. Time to get out your calculator. Our first step is to rewrite the question. Then look at the formula sheet and rewrite the formula for parabolic functions. The values for a, b, and c are 3, -5, and 1 in this case. Now, we write the formula with these substituted values so that it's easier for us to punch it into our calculators. Again, if any of you would like for me to explain this formula, comment down below. We should get two answers. One is 1.434, which we round to the first decimal, which is 1.4, and the other 0.232, which we round to 0.2. Full marks. Question 1.1.3 asks us to compare two functions. If we plot these functions, we see that they cross at points 0.3331 and 1.33316. What the question really asks is, for which values of x is the function on the left smaller than the function on the right? We are interested in the points at which these functions cross, similar to question 1.1.1. We need to balance the equation so that one side equals 0. No takeover, don't take over anything. Balance. Now we are going to factorize this parabolic function into brackets. I'm doing this by shorthand again, but you are more than welcome to use the calculator method as in question 1.1.2. You should get the same answer. Now that we have these intersection points, we can compare the equations. Remember what the question is. If we draw a positive parabol that intersects the x-axis at 1 over 3 and 4 over 3, we see that x needs to be less than 1 over 3 or greater than 4 over 3 for the equation on the left-hand side to be less than the equation on the right-hand side of the question. Remember to report the values of x correctly. Many of my students miss out on full marks because they failed to write this last line. Question 1.2 asks us to solve x and y simultaneously. But what does this mean? Well, if we plot these formulas, we see a straight line that intercepts what looks like a weird hyperbolic function. The straight line crosses the weird line at point 2.5, negative 0.5, and 0.52. This question can thus be interpreted as find the xy pairs that will satisfy both these equations, or find the points at which these two functions intercept. Time for some more algebra. First up, we rewrite the two equations and label them as 1 and 2. To solve this math problem, we need to substitute one equation into the other. In this case, it is way easier to substitute 1 into 2. But first we need to simplify equation 1 so that either x or y is alone on one side of the equation. Again, there are no takeovers, only balance. Now let's substitute equation 1 into equation 2 by writing 3 plus y where there is an x. I like to write out these tricky equations so that they are easier to work with. Then I like to shuffle the terms around again to make it easier for myself. This will eliminate a lot of mistakes that could slip in. It's the foolproof way to get 100%. Algebra time! After simplification, we see that we have a negative parabolic function. We can multiply both sides of the equation with -1 to make life easier for ourselves. I'm solving this the shorthand way. You are more than welcome to try the calculator way. Either way, make sure you do it in a manner that eliminates the possibility for mistakes. Don't do stuff in your head, write it out. Cool. Now that we have our two y values, we can substitute them into our equation 1 at the top of our page. We underline our answers to make it easier for the person marking our work. Full marks! Okay, so question 1.3. What a mess. Note how the show all calculations is actually a low-key threat. We are not going to get full marks if we use our calculators. This question is testing our exponent knowledge. We need to know that the square root of 10 empowered x plus 1 can be rewritten as 10 empowered x over 2 times 10 empowered half. We are going to use this identity to simplify this question and to secure those marks. The rest is messy algebra that you need to keep track of. For this question, it's critical for us to take small steps and to write them out. We are going to break 10 empowered thousands into 10 empowered 1003 as the smallest denominator. This helps us simplify the question without using a calculator. If you struggle with this question, watch this video at half speed. Also, questions? Comment section! Question 1.4. This is the last question for this video. It tries to scare us with the square root, but we're not easily scared because just like in the other questions, we are taking small steps and writing everything out along the way. A cool trick we can use here is to substitute square root 4 into 2 so that the second and fourth terms cancel out. Easy! Full marks! Thank you so much for watching. Please remember to leave a thumbs up if this video helped, and please leave a comment if you have a question or if you struggle doing this yourself. I would actually really love to help you, but sorry for the trash quality. I'm using my phone camera and the mic on my cheap headset, but I know you learned something in this video, and we tackle question 2 in the next video, so go ahead and watch that when it's up. Cheers!